So in this lecture, we are going to take the cases case by case, different coupled oscillator systems. Since we've understood how to solve a coupled differential equation or how to decouple a coupled differential equation, let us dive into the physics part. Okay, so let us dive into the physics part. So let us take the first case and an easier one. An easier one means we are not using different masses. We are not using different spring constants. We are keeping this. The first very simple case that we are going to study is called as you can say the case for this is the case. And these frequencies, these spin constants are same k, and k. All of them are k only, and the masses are same. So I'm discussing a case where you have two masses, like two similar masses, the two equal masses are there, and three springs attached as shown, with same elastic, with same you can say, what you should say, elastic constants. Okay, you can say spring constant instead. This is the first case that we are doing in the cases for the coupled oscillators. So we are discussing something called as your coupled oscillators. Okay, so it is the easiest of the easiest case. Okay, so it is easiest of the easiest case that we're discussing, and we'll try to we'll try to use both the methodologies that we've developed. But lately, you will see that I will most often I'll resort to the second strategy. Okay, the second strategy of assuming a trial solution, that would be the best approach, because you'll see that certain like the similar structure you'll find it in Lagrangian formalism also. So I'll suggest you to resort to the second, but I'll do it in the both of the manners. Okay, and having said that, I know that although the first approach is quite easy, because like you can say I could solve it in like hardly 1 minute or 2 minutes, but not often you will find that making such linear combinations is is that easy. For example, here you can do so, but not always. Okay, however, I'll try my level. I'll do the both of the approaches here, but lately I'll not do. Okay, lately I'll, like for example, for more intricate difficult cases, we'll resort to the second approach. So if there are two masses, and for simplicity I'm taking both of these masses are equal, and even the spring constants are equal. Although we'll probably tomorrow take a case where we'll consider weak coupling, and weak coupling means I'll take this particular constant as some having a weaker spring constant than the other ones. But today we're taking an easier case. Let us start with the easiest of easiest case, that is this. Okay, and in order to execute this, so what we do actually, whenever we have to do an oscillation thing, what we do, we try to uh, we try to uh, slightly displace this particular mass from its equilibrium position. So let us say this is your equilibrium position, and if you displace it in this direction, both of them in a similar direction, let's say in this direction x1, and here in this direction as x2. And let us, for simplicity, assume that the displacement x2 is slightly greater than x1, so that at least some physical situation is perceivable. So for example, if this is the case, so what will happen? So your mass will come here. It has been displaced by x1 here. And this mass will again get displaced here. So there will be, this mass is displaced by x2. And this is how it is. Okay. So this particular spring has been extended. And this particular spring has been compressed. And understand that if x2 is greater than x1, then this particular spring, the middle spring, has also got elongated. Is that clear? Now, consider the dynamics of mass first mass. That is, the first mass is mass m. So this mass, you have to see what is the dynamics of this mass. So the dynamics of this mass would be, what is the force exerted on this mass? This is the first thing that we need to see. So what will be the force exerted on the first mass, the left one? So I'll write the force on this will be like minus kx1. See, if you're extending, so it acts in opposite direction. Is that clear?
Yes.
ओके एंड ये वाला जो चल रहा है, इसका टोटल नेट इफेक्टिव डिस्प्लेसमेंट कितना हो चुका होगा? x2 minus x1. So it is like it is being pushed in that direction.
Right.
Okay, so what will happen here? It will this way, and here you will have this x2 minus x1. So is that clear or not clear? So for example, this is being pushed against, this has been pushed against like इसको अगर आगे लेके जाओगे तो x2 हो जाएगा, ये आगे x2 गया. So it is being compressed, so it will feel a force here in this direction. Is that clear?
Yes.
Okay, and because it is being compressed, so sorry, since it is being compressed, सो लाइक इसको पकड़ लेते हैं, ये वाला मास पकड़ लेते हैं, सबसे पहले लेफ्ट मास पकड़ते हैं. तो लेफ्ट मास के ऊपर फोर्स क्या लग रहा है? एक तो इस डायरेक्शन में लगेगा, दिस विल बी लाइक kx1, and I'm writing minus because it is in the negative direction. Is that clear? And also understand there would be, because it is being getting elongated in this direction, so I should write kx2 minus x1. So this is about the first, because the masses are, so I'll write it here left mass, ऐसा लिखो left mass. Is that clear? What about right mass? What about right mass? So on the right mass, what it is feeling, it is getting pushed by this. This will be like minus kx2, because this particular spring is getting compressed.
Right.
Okay, and the second one, if you see, if x2 is greater than x1, what will happen? It is pushing in this direction. So again, it will feel, it will in this direction, it will have this k x2 minus x1. Is that clear or not clear? See, देखो यहां से it was getting elongated, right? तो देखो इस mass के लिए यहाँ elongation है. The spring is like pressing like away from it, and on this mass there is a force on, like it is pushing in this direction, and because if displacement is in this, so what will happen? It will try to restore. And one way is like, you can see that this is your second mass. It is getting compressed by x, like इसको इसको मैं कैसे समझाऊं? ये चीज जो समझ रहे हो, ये x2 आगे गया होगा, then obviously this wants to retain here, and ये जो बीच वाला स्प्रिंग है, ये इसको तो खींच रहा है, लेकिन इसको कंप्रेस कर रहा है, इसको ये थोड़ा प्रेस कर रहा है. So obviously if this particular force is acting here, the restoring force will be in this direction for the second mass. तो सेकेंड मास के लिए दो रिस्टोरिंग फोर्सेस हैं. वन रिस्टोरिंग फोर्स क्यों आएगा? बिकॉज ऑफ द कंप्रेशन हियर, and that will be minus kx2, and another compression is due to this. So basically what is happening, if it is getting elongated, if x2 is greater than x1, it is getting elongated, so your mass m is going in this direction, but on mass m you are having this like kx2 minus x1 is pressing, like this particular spring is pressing against, and so in order to restore, it will have to have a restoring force in this direction, that will be minus kx2, and there will be again a kx2 minus x1. Is that clear or not clear?
Clear.
Clear. So your mass number one, I should say your mass number one should have the equation as mx1 double dot is equal to minus kx1, and then you should have sorry plus होगा ना, तो plus there will be kx2 minus x. इसमें एक नेगेटिव पॉजिटिव कर दिया, बस खत्म है फिर अपना क्वेश्चन, फिर कभी जिंदगी में नहीं सॉल्व होगा. तो थोड़ा सा देखना पड़ेगा. देखो ऐसा समझो, ये मास m है, it is getting, because this spring, अगर मैं x2 को x1 से ज्यादा मान रहा हूँ, if I'm taking x2 greater than x1, so it is getting elongated, so it is going to take it there, or it is also going there. So x1 से आगे जा रहा है, Are you getting my point? But point is this, since x2 is greater than x1, so it is going to get elongated only in this direction. So the net restoring force will be minus k x1. And another one is that it is again feeling a force in this direction because x2 is greater than x1. So obviously this spring is getting elongated. So this is getting elongated here. The other mass is having another problem. So another mass is pressing, because here there is a wall. This is a rigid wall. So if you are taking, if you are displacing it in x2, so one thing is that it will have, like initially it was not this way, ना? So it was not this way. So it is getting, you can ऐसे समझो, जैसे कि मैं कैसे समझाऊं इस चीज को, जैसे कि ऐसे समझो, जैसे कि यहाँ से यहाँ तक ये था इक्विलिब्रियम पहले, ठीक है, और अब ये आ गया है x2 तक. सो नाउ दिस गेट्स कंप्रेस्ड बाय एडिशनल x2. लाइक जितना डिस्प्लेस हो उतना ही तो कंप्रेशन आएगा. इस कंप्रेशन की वजह से इट विल फील अ फोर्स इन दिस डायरेक्शन माइनस के x2. Another problem is, since x2 is greater than x1, and since x2 is greater than x1, so it will feel a push from this spring. So in order to restore in this direction, it will have another force that is minus k x2 minus x. Is that clear or not clear? I think this is quite clear now. जितना मैं समझा पा रहा हूँ, बिकॉज इसमें एक एरर जो होती है बच्चों से, दैट इज ओनली ऑफ द साइन. mx2 डबल डॉट एंड क्या कह सकते हैं, मतलब ये एक्शन एंड रिएक्शन वाली बात ही समझ लो, ऐसे समझो. माइनस दिस विल लाइक माइनस के x2 एंड दिस विल बी लाइक माइनस के x2 minus x1. Is that clear to you? This is your equation number 2. So again, this is a coupled differential equation. This is a coupled differential equation. हाँ जी बोलो.
नहीं, आ गया समझ.
So how to decouple it? The first way that I taught you was to write it in some form of linear combination. So let us write it in linear combination. So linear combination would be to write mx1 double dot x2 double dot is equal to minus k x1 plus x2, and then you have this plus k x2 minus x1 minus क्या है ये k x2 again and plus k x1. So you will have again x1 plus x2. ठीक है, this is your equation number 3rd. And you subtract, if you subtract both of them, so you'll have m x1 double dot minus x2 double dot equals to, sorry, plus equals to, चलो घटा ही देते हैं, तो ये कितना है, minus k, and you have this, if you take minus common out, so this will be like minus k minus x2, and then you have plus k, and you have this x2 minus x1 and 2 times. So overall you can write your second differential equation as m x1 double dot minus x2 double dot as minus 3k x1 minus x2. This is your equation number 4. Is that clear? Okay, and you know from your standard 12 that your k by m is your omega square. That is something that you know. Okay, so that is the natural frequency of the oscillations given by k by m. Okay, so if I write my x1 plus x2, so this is x1 plus x2, this is d2 upon dt square, and this first equation suggests you that plus omega square x1 plus x2 equal to 0. So one of the normal coordinates is x1 x2, and it oscillates with a frequency omega. It oscillates with the frequency omega. And what about the second oscillation? Like second normal coordinate d2 upon dt square x1 minus x2 plus omega square x1 minus x2 equal to 0. This will oscillate with a frequency 3 omega. Not 3 omega, root 3 omega. Because you see, this is 3k by m, this is 3k by m. So if you replace like k by m as root k by m as, are you getting my point?
Right.
Okay, so this will oscillate with the frequency root 3 k omega. So what you can do, you can just replace k by m as omega square. Okay. So frequency of oscillation here will be root 3 omega. The frequency of oscillations here would be omega. Is that clear? And if you try to take the sum and difference, and if you want to find this x as a function of t, so your x as a function of t would be some constant. What should I do? I should write as some constant let's say इसको लिख देते a, and let us write it as cos omega t plus phi 1, and then plus you write a1 and you write a2 here. This will be cos 2 omega, root 3 omega t plus phi 2, and you write y as a function of t. This will be like v1 cos omega t plus phi 1 minus v2 cos root 3 omega t plus phi 2. But these are like quite unpleasant to see that these are having the linear combinations of two different sinusoidal functions. One of them is oscillating with omega, another one is oscillating with root 3 omega. However, you can see that x1 plus x2, this is one such, you can say coordinate, or you can say mode, I should not say mode. This coordinate oscillates with a pure frequency omega, and another one also oscillates with a pure frequency root 3 omega. Is that clear? So these x1 plus x2 and x1 minus x2 here are called as your normal coordinates. Is that clear?
Yes.
Yes. Okay. Now another way that we developed was to see was to use the trial solution. The second method that we developed was called as the method by assuming some trial function. So let us assume some trial function, and that trial function, let it be x as a function of t. You should take a. I took e ki power iota alpha t, and you take x2 as a function of t as b e ki power iota alpha t. Okay, and you know instantly that from the differential equation itself, that for the non-trivial solution, we arrived at a point that we said that the determinant should be like, you can say, you take these two, I should write these two coupled differential equations so that I don't have to see it all over again. So this is my coupled equation. Rather, I should write plus omega square x1 plus x2 equal to 0. And here I should write plus 3 omega square. And here I should write x1 double dot minus. Okay. Now, if I write x1 as a e ki power iota alpha t, what I will get? I would simply get in the first equation, this is your first, this is your second, this will be like minus alpha square a e ki power iota alpha t plus again this one like minus alpha square b e ki power iota alpha t plus omega square, and then you have a e ki power iota alpha t, and then you have b e ki power iota alpha t equal to 0. Another one is minus alpha square a e ki power iota alpha t, and then you have minus plus alpha square b e ki power iota alpha t plus 3 omega square, and then you have a e ki power iota alpha t minus b e ki power iota alpha t equal to 0. So if you have these all of these terms, then what I can do, I can take e ki power iota alpha t as common out. Okay, I can take this as common out, and what I'll get minus alpha square plus omega square. Sorry, not omega square. पहली वाली इक्वेशन से क्या आ रहा देखो,
तो ये माइनस अल्फा स्क्वायर क्यों हो रहा है?
x1 डबल डॉट करोगे तो क्या आएगा, a e की पावर आइटा डबल डेरिवेटिव में माइनस अल्फा स्क्वायर ही तो आएगा.
अच्छा, ओके ओके, ठीक, वो भी अलग आया था.
और x2 डबल डॉट में माइनस अल्फा स्क्वायर b a आना चाहिए प्लस ओमेगा स्क्वायर a e की पावर आइटा अल्फा t ही आना चाहिए. आई डोंट थिंक इसमें कोई दिक्कत है. सो इसको एक बार ढंग से लिख ही लेते हैं, तो वही गलतियां होंगी. गलतियां मुझे करनी नहीं अभी, because once we'll do a mistake, then things will go completely wrong from here. Okay? हम लोग इसका थोड़ा सा और डिफिकल्ट वेरिएंट भी करेंगे कल, पर अभी के लिए आज इजी वाला पहले कर लेते हैं फटाफट से. सो ठीक है, here it is. So I'll write it as ओमेगा स्क्वायर यहाँ पर बैठा हुआ है. चलो देखते हैं. सो व्हाट आई एम गेटिंग इज x1 प्लस x2 डबल डॉट. इसको कैसे सेट करेंगे, एक रुको मुझे 2 मिनट दो. why I'm not getting it, or am I doing some mistake? अच्छा, कपल्ड ऑसिलेशंस लिख दिया ना मैंने, अपने को ये तो नहीं लिखने थे. दीज आर तो कपल्ड ऑसिलेटर्स. हमारी डिफरेंशियल इक्वेशन तो ऊपर ही रहेगी ना. ओरिजिनल डिफरेंशियल इक्वेशन कहाँ गई, ये रही। शिट। सो ओरिजिनल डिफरेंशियल इक्वेशन वाज दिस, ठीक है। हम तो इसको यूज कैसे कर सकते हैं, बेवकूफी कर रहे हैं, ये तो दूसरा मेथड था ना। सो इन ट्रायल मेथड हम क्या करते हैं, वी ट्राई टू यूज द ट्रायल सोल्यूशन इन द ओरिजिनल डिफरेंशियल इक्वेशन। सो ओरिजिनल डिफरेंशियल इक्वेशन क्या थी वो देखते हैं, सॉरी, ये तो नॉर्मल मोड्स वाली इक्वेशन होगी, राइट। अभी हमारे पास क्या था, ये तो हमारी इक्वेशन होगी जो हम जोड़ के और घटा के ला रहे थे। दिस इज नॉट द थिंग ना। हमारा क्या था, हमारा ये था। सो हमारा फर्स्ट मास के ऊपर क्या क्या लग रहा था, हमारे फर्स्ट मास पे x1 double dot m was equal to minus k x1, and then you had force plus k x2 minus x1, isn't it? ये थी forces. This was your first. करो इसको ना फटाफट से रखो, x1 कितना आएगा minus m, and you have this alpha square a, इस m को भी नीचे कर देते हैं, मैं ढंग से लिख देता हूँ तो लाइफ इजी रहेगी तुम्हारी। So this will be like x1 double dot is equal to, और you can say सब प्लस में ले आओ, प्लस k by m x1 minus k by m x2 minus x। इज दैट क्लियर? वो एक्चुअली क्या हो रहा था कि अपन लोग गलत कर रहे हैं ना, बिकॉज वो तो इक्वेशन भी, ये जो इससे जस्ट पहले वाला मेथड था उसकी इक्वेशन थी, दिस इज तो मेथड वन। मेथड वन में हम क्या करते थे, वी यूज्ड टू ऐड देम अप एंड सबट्रैक्ट देम। इक्वेशन तो ये है ना, हमारी लेफ्ट मास के ऊपर लगने वाली इक्वेशन ये थी, राइट मास के ऊपर ये है, तो x1 की जगह हमें सोल्यूशन रखना है a e की पावर आयोटा अल्फा टी। सो a e की पावर आयोटा अल्फा टी यहाँ रखोगे और b e की पावर आयोटा अल्फा टी यहाँ रखोगे। हालांकि उससे भी आ जाता, पर कोई बात नहीं, इससे भी देखते हैं। सो इससे क्या आएगा, माइनस अल्फा स्क्वायर ए ई की पावर आयोटा अल्फा टी, एंड देन दिस विल बी लाइक 2 k by m a e की पावर आयोटा अल्फा टी, है ना, एंड देन दिस विल बी माइनस k by m b e की पावर आयोटा अल्फा टी इक्वल टू 0। इज दैट क्लियर? ये चीज समझ में आई? एंड दूसरी इक्वेशन क्या थी, याद करो, दूसरी इक्वेशन में x2 डबल डॉट था, you had minus k x2 and you also had minus k x2 minus x1, because you see x2 was greater, so it was, this spring was pressing against, so in order to restore back, there should be a force minus k x2 minus x1. So in any case, in this particular, for this particular equation I can write minus alpha square b e की power iota alpha t, and then this is plus k by m b e की power iota alpha t, and then this is plus k by m b e की power iota alpha t minus a e की power iota alpha t is equal to 0. Is that clear or not clear at all?
Yes.
Okay, so let us first write all these terms. So this is minus alpha square plus, एक काम करते हैं, 2k by m को लिख देते हैं 2 ओमेगा स्क्वायर, है ना, देखो ये, and this term is minus omega square, and this term is ऐसा इधर की तरफ क्या आना चाहिए, देखते हैं। सो अगर इधर की तरफ देखें तो क्या आना चाहिए, यू हैव अनदर टर्म विच इज इन ए। ए में क्या है, देखो ए में टर्म है आई थिंक माइनस ओमेगा स्क्वायर अगेन, ये रहा, और बी में टर्म्स क्या क्या है वो चेक करें। सो माइनस अल्फा स्क्वायर प्लस 2 ओमेगा स्क्वायर, दिस multiply this entire matrix multiplied by a and b equal to 0. Is that clear? देखो ध्यान से, मैंने क्या किया, this equation number you can say 2, this was equation number, let's say 3, this was equation number 4. So I have written 2 and 4 in matrix form, because e की power alpha t should be non-zero, so that part. Is that clear?
Yes.
Okay, so if I solve this particular differential equation, what I'll get, alpha ki power 4, if I solve, I know that a non-trivial solution, would exist, a non-trivial solution will exist if this determinant is 0. So let's say, let me write this as f. So if this determinant is 0, then it implies that there would be a non-trivial solution. And if this non-trivial solution exists, if this non-trivial solution is to exist, then what does it mean? It means that minus alpha square plus 2 omega square ka whole square, and then you have minus omega ki power 4 has to be 0. Is that clear to you? And so if I just use this up, this will be like alpha ki power 4, and then you have this, minus 4 alpha square omega square, and then you have plus 3 omega ki power 4 equal to 0. I hope it is clear. So again, if you try to solve this one, you will get, you take alpha square as y. So if you take alpha square as t or y something, so this is alpha square का whole square, and this is minus 4 alpha square. To take this alpha square as one variable, this is minus, and this is 3 omega square equal to 0. So what does it mean? It means alpha, हाँ जी,
3 ओमेगा रहेगा.
क्या बोल रही है? Alpha square minus 3 omega square, and this will be alpha square minus, आवाज आ रही है नहीं आ रही है?
Yes, आ रही वो रूट्स बता रही थी.
अच्छा अच्छा अच्छा, सॉरी सॉरी. So this is like alpha is equal to plus minus root 3 omega here, or alpha is equal to plus minus omega. Is that clear? ये समझ में आ गया बेटा? ठीक है.
Yep.
So these are the roots which we also we got from our other way of solution. So होता क्या है? Why I'm doing this time and again? Because if you see more complicated situations, you'll find that this is more effective way to do things. Rather, this is an easier approach, but again I'm saying, reiterating, that in order to write all these things in linear combination is not that easy. So if in exam it comes and if you find अच्छा कुछ करके -2 मल्टीप्लाई करके या +2 मल्टीप्लाई करके कुछ और मतलब अलग कॉन्टेक्स्ट में अगर ये चीजें सेट हो सकती है, then try. If that don't happen that way, then don't worry about it. Like that's it. Like then go for this approach which I'm stating right now. Okay, so corresponding to alpha equal to plus minus root 3 omega and corresponding to alpha is equal to plus minus omega, let us first find what is the relation between A and B. So if I use alpha equal to plus minus root 3 omega, and what was it? It was it minus alpha square, sorry, minus alpha square to omega square, and I had minus omega square. I had minus omega square here, and I had minus alpha square plus 2 omega square. And then I will write A and B here equal to 0. If you do that, and if you replace this alpha as root 3 omega, so you will get, I think this will be omega square here, minus omega square here, minus omega square here, omega square here. So this is like A and B. And from here you can see that your A should be equal to B. So again, this is your symmetric mode. This is your symmetric mode. And the other one, that is alpha equals to plus minus, what was that? Omega only. कुछ गलती करी क्या? Alpha equal to plus minus, sorry, alpha equals to plus minus root 3 omega के लिए आएगा ये minus, this will be minus, this will be A minus B, this will be anti-symmetric one. And alpha equal to plus minus omega रखोगे तो क्या आएगा? It will be omega square minus omega square, and then you will have this minus omega square, and then you will have omega square, and you have A and B here. So from here you will get A equals to B. So this is a kind of symmetric one. What does that mean? We'll see that. Don't worry. So this is an anti-symmetric one. What is that anti-symmetric one I'm saying? I'll come to that. But right now, just understand, since A is equal to minus B, I'm writing this particular, you can say, V of oscillation as anti-symmetric one, and this one as symmetric one. Okay. And if you want to write the entire solution, as I did in the previous lecture also, you can do that also. So instead of X and Y, you have X1, X2 written over here. Your A1 would have 1, 1. Okay, because A equal to B, so A1 equal to this one, and e की power iota omega t. You can write your A2 as 1, 1, but now you will have e की power minus iota omega t. Your third term will be A1 minus 1, and you will have e की power क्या था iota root over 3 omega t, and then you will have this A4 1 minus 1, and I think it was e की power minus iota omega root 3 omega t. Is that clear? So this is how you can write your solutions also. Okay, but understand, in the previous lecture also, when I was doing the coupled oscillators, okay, I was doing a coupled oscillator. In order to obtain x1 plus x2, in order to obtain x1 plus x2, I have to shut this off. I don't need x1 minus x2 there. In order to have x1 minus x2, I don't need x1 plus x2. Is that clear? So there are two modes. Clearly, you can see in the previous thing also, you saw that there are two modes. One mode is x1 plus x2, and another mode would be x1 minus x2. Is that clear? So one normal coordinate was x1 plus x2, and another normal coordinate was x1 minus x2. Is that clear or not clear? कि मैं वापस समझा इसी चीज को. देखो यहाँ क्लियर था ना? जस्ट ऊपर जो हमने किया, जस्ट ऊपर सो किया, देखो यहाँ पे वन नॉर्मल कोऑर्डिनेट वाज x1 प्लस x2, अदर नॉर्मल कोऑर्डिनेट इज x1 माइनस x2। इसको नॉर्मल कोऑर्डिनेट बोलेंगे, और जो फ्रीक्वेंसीज आएंगी और जो a और b में रिलेशन आएंगे उसको हम नॉर्मल मोड्स बोल देंगे। ठीक है, नॉर्मल कोऑर्डिनेट्स क्या है? वो कोऑर्डिनेट्स जो a की फ्रीक्वेंसी से ऑसिलेट होते हैं। तो x1 माइनस x2 किस फ्रीक्वेंसी से ऑसिलेट हो रहा है? हटाओ इसको, मेरे को फिर लिखिए यहाँ पर 3 ओमेगा स्क्वायर, है ना। और x1 प्लस x2 किससे ऑसिलेट कर रहा है? ओमेगा स्क्वायर से। तो इसको x1 प्लस x2 को बोलते हैं वन ऑफ द नॉर्मल कोऑर्डिनेट, मतलब एक ऐसा कोऑर्डिनेट जो एक प्योर फ्रीक्वेंसी से ऑसिलेट हो। सो x1 प्लस x2 is oscillating with frequency omega. x1 minus x2 is another normal coordinate which is oscillating with frequency 3 root 3 omega. Is that clear? Not clear?
Yes.
Clear.
Clear.
Good. तो है ना, क्लियर है ना, यहाँ तक तो कोई दिक्कत नहीं। और इन अदर वर्ड्स अगर ऐसा सोचें तो इधर की तरफ सोचें तो ठीक है, ठीक है। So this is oscillating with frequency omega and this is oscillating with the frequency root 3। Is that clear? ठीक है। और जैसा पहले किया था, you can replace your a1, I'm writing, you can replace your a1 as e की पावर iota phi 1 by 2। You can replace your a2 as e की power minus iota phi 1 by 2। Why I'm doing this? Because then all this will result into a cosine form, and since your x1 and x2 are real, so obviously we only want real part, we don't want imaginary part. So this is what we do. Okay, so a3 I can write it as e की power iota phi 2 by 2, and a4 I can write it as a की power minus iota क्या था ये क्या कह सकते हैं आप इसको, phi 2 by 2। Is that clear? And if I replace all these things, so if I replace x1 x2 की x1 x2 equals to a1 की जगह ये लिखते हैं, so एक ही स्टेप में लिखूंगा मैं a1, ठीक है, 1 1, और इसको एक काम करते हैं a1 की जगह कुछ नया नाम दे देते हैं, लेट्स से a1 डैश नहीं बोल सकते, चलो b1 बोलते हैं इसको, b1 बोल दिया। ठीक है, so b1 1 1, here you will have cos ओमेगा टी प्लस 5 1, पहले भी किया था ये चीज, इसलिए मैं रिपीट नहीं करूंगा। b2 will be b2 into 1 minus 1, and here you will have cos root 3 omega t plus 5। Is that clear or not clear?
Yes.
ठीक है, सो अब देखो मेरी बात सुनने की कोशिश करो, अगर तुम x1 प्लस x2 लिखते हो तो तुम्हारे पास सारा का सारा टर्म किस में आएगा? सो योर b2, सो देखो ना, अगर x1 प्लस x2 लिखोगे तो व्हाट विल हैपन, देखो x1 क्या होगा, b1 cos omega t plus phi 1 b2 this thing, and b1 cos omega t phi 1 minus b2। so if x1 plus x2 करोगे, so what will happen, b2 will disappear। is that clear? अब अगर x1 minus x2 करोगे तो b1 term will disappear। is that clear or not clear? So what you can do instead, so in order to achieve one of the modes, at one of the coordinates you want to achieve, what I can do, I can place b2 equal to 0 for this case, and for in order to achieve this, I can replace b1 equal to 0। Is that clear?
Yes.
So for this normal coordinate, for this normal coordinate, what I can do, I can replace my b2 as 0, because in any way b2 is going to disappear if you see. So b2 is going to disappear, and for obtaining this normal coordinate, you place b1 equal to 0. So you will get the requisite for this normal coordinate. Now, corresponding to this normal coordinate, if I place my b2 is equal to 0, if I replace b2 equal to 0, what is the mode I'm left with? I'm left with only this mode. This is called as your normal mode. Or you can say this is the mode where your a is equal to b, if you remember. Okay, and corresponding to this coordinate, another normal mode you will get. That normal mode is 1 minus 1. For this case, you know that your a was equal to minus b. So what is happening? Your the amplitude of x1 is A and amplitude of x2 is negative of that. And similarly here, amplitude of x1 and amplitude of x2 both are following the same they're following the same sign as well as the magnitude. Is that clear to you?
Clear.
Okay. So let us now physically understand what does that mean. Okay. So I'm considering normal coordinate. What was the normal coordinate number one? The normal coordinate number one was x1 plus x2. It was oscillating with a pure frequency, which is called as your normal frequency. And this is equal to what? Omega. And corresponding normal coordinate you can represent as 1, 1. So this was your normal mode. Now, how to visualize it? In order to visualize it, what you can say that if this is 1, 1, or in other words, normal coordinate x1 and x2, when you will only get if your this term will disappear. Is that clear? If this term disappears, then you'll have this kind of mode. Is that clear?
Yes.
Okay. So what should I say? I should say that if B2 disappears, or in other words, if I write that B2 instead of B2, I should write again that B1, the 1 minus 1 should disappear. That is, this entire thing should be 0. Okay. And what does it mean? It means that what was B1? B2, what was B2? Sorry. थोड़ा सा ध्यान से देख, थोड़ा सा कॉम्प्लिकेट हो गया ये. So ऐसे ना देखें तो ऐसे देखते हैं. So अच्छा, B2 was corresponding to what? B2 was corresponding to what? एक मिनट थोड़ा ध्यान से देखते हैं. रुक जा. कंफ्यूज हो गए, नहीं तो कंफ्यूज हो गए. दिस वन 1 माइनस 1 किसके corresponding था? इस फ्रीक्वेंसी corresponding √3 ओमेगा के corresponding. ठीक है, √3 ओमेगा के corresponding जो मोड है वो 0 होना चाहिए, राइट? √3 ओमेगा के corresponding मोड 0 होना चाहिए. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि कि जब √3 ओमेगा था तो एक मिनट यार, अपन कुछ गलती कर रहे हैं जल्दीबाजी में. प्लीज देखो इधर कहाँ गया ये सब. ऐसे करा रहे तो हवा में करते. 2 मिनट लगेंगे मुझे. ये समझ में आ गया? यहाँ तो कोई दिक्कत तो नहीं. सो वन ऑफ द नॉर्मल कोऑर्डिनेट इज x1 प्लस x2. द नॉर्मल फ्रीक्वेंसी इज ओमेगा. और नॉर्मल मोड इसके corresponding क्या था? मैं ऐसे करा देता हूँ, तुम्हें ज्यादा आसान हो जाएगा. बिना द टाइम वेस्ट होगा. दिस विल बी 1 1. इज दैट क्लियर? 1 1 मींस व्हाट? 1 1 मींस व्हाट? दैट इज ऐसा हो गया x1 x2 ऐसा समझो. चलो इधर था 1 1 एंड हियर इट वाज cos omega t plus 5. Is that clear? इसका मतलब क्या है? For this mode, your x1 is also equals to some constant. यहाँ constant क्या था यार? I think a1 था या b1 था. This was b1 cos
B1.
omega t plus 5 and x2 was also b2 cos omega t plus 5. So what does it mean? It means that both x1 and x2 are traversing in the same direction. It means what? Both are traversing in the same direction and both are like oscillating in the same manner. Are you getting my point? b1 plus b1 cos omega t. तो होगा क्या? ये both are oscillating back and forth in the same direction. देखो दोनों oscillations की जो equations हैं बिल्कुल same. Is that clear or not clear?
Clear.
Clear? So इसका मतलब क्या हुआ? इसको अगर तुम थोड़ा सा visualize करोगे तो what is happening? If mass left mass is going forward, then your right mass is also going forward. So this is a kind of symmetric motion. And you see that this symmetric motion would be accompanied by omega only because इसमें कोई फर्क ही नहीं पड़ रहा कि ये है या नहीं. This spring का कोई फर्क नहीं पड़ रहा. Basically, this is also oscillating, this is oscillating, and again it will oscillate back, it will again oscillate. Is that clear? But when you consider the second mode was corresponding to 1 minus 1. This was your second normal mode. The corresponding frequency was √3 plus minus √3 omega, if you remember. For this mode, you know that your x1 would be equals to some b2 cos omega t plus phi 2, but your x2 will be equals to what? Your b2 negative में cos omega t plus phi 2. Now what is happening? If one of them is moving in this, if left mass is moving in this direction, your right mass is moving in this direction. See, negative. So like if it is oscillating in this direction, it will oscillate in this direction, and if it will oscillate in this direction, then this will oscillate in this direction. This is your anti-symmetric mode. Is that clear or not?
हाँ भैया.
And why this is happening? Because if they're moving in opposite direction, now this spring comes into frame. This spring comes into frame because now it is going to either get stretched if both are coming towards, if both are coming towards, then it will get compressed. And if both of them are moving apart, then this is going to get elongated. Now you'll say, what is the reason? Why do you say that this will come into frame? Because now if it is getting compressed, it is going to push these two in other directions. So obviously it is going to counter more force. These two masses are going to feel more force. And since they're going to find more force, that is getting reflected in their angular frequencies as well. Is that clear to you?
हाँ भैया.
Okay, so this sums up your easiest case. However, थोड़ा सा गलत हो गया बीच में, so kindly take a note of it. But overall, ये समझ में आ गया ना? So tomorrow we'll take the case for 3, and probably tomorrow itself we'll take the case of an n-dimensional case, so that things get done. Is that clear? Okay, take care.